Now, a team of researchers has combined theoretical predictions and sophisticated imaging algorithms to remaster the original imagery of the supermassive black hole at the center of the galaxy M87, first captured by the Event Horizon Telescope (EHT) in 2019. Their findings, published today in the Astrophysical Journal, are consistent with theoretical predictions and offer new ways to explore these mysterious objects, which are believed to reside at the hearts of most galaxies. The approach we took involved leveraging our theoretical understanding of how these black holes look to build a customized model for the EHT data, says Dominic Pess, a study co-author based at the Center for Astrophysics Harvard-Smithsonian and member of the EHT collaboration. Our model decomposes the reconstructed image into the two pieces that we care most about, so that we can study both pieces individually rather than blended together. The result was made possible because the EHT is a computational instrument at its heart, says Avery Broderick, who led the study. It is as dependent on algorithms as it is upon steel. Using 8 observatories on 4 continents, all pointed at the same spot in the sky and linked together with nanosecond timing, the EHT researchers observed 2 black holes in 2017. The M87* image that scientists unveiled in 2019 was a landmark discovery, but the researchers felt that they could still sharpen the image further and glean new insights. By applying their new software technique to the original 2017 data, the team was able to focus the data's constraining power on phenomena that theories and models predict are lurking beneath the surface. As we continue to add more telescopes and build out the next generation EHT, the increased quality and quantity of data will allow us to place more definitive constraints on these signatures that we're only now getting our first glimpses of, says co-author Paul Teed, a CFA astrophysicist and EHT. Make a difference. Sponsored Opportunity StorySource. Materials provided by Harvard-Smithsonian Center for Astrophysics. Note: content may be edited for style and length. Journal reference: Avery E. Broderick, Dominic W. Pess, Roman Gold, Paul Teed, Hung Yi Pu, Richard Anantua, Silke Britson, Chiara Cecobello, Kushik Chatterjee, Yongjun Chen, Nicholas S. Conroy, Jeffrey B. Crew, Alejandro Cruz Osorio, Yuzhu Kui, Shepard S. Dolman, Razia Amami, Joseph Farah, Christian M. Frum, Peter Gallison, Boris Georgiev, Luis C. Ho, David J. James, Britton Jeter, Alejandra Jimenez Rosales, Jun Yi Koei, Karsten Kramer, Thomas P. Crickbaum, Sang-Sung Lee, Michael Lindquist, Ivan M. The Photon Ring in M87. The Astrophysical Journal, 2022. 935. 1, 61 doi. 10. 3847 1538-4357, AC7C1D. Cite this page. Harvard-Smithsonian Center for Astrophysics. Ready for its close-up, new technology sharpens images of black holes. Science Daily, 16 August 2022. ift.tt/lsgz1wq. Harvard-Smithsonian Center for Astrophysics. 2022, August 16. Ready for its close-up, new technology sharpens images of black holes. Science Daily. Retrieved August 16, 2022 from ift.tt/lsgz1wq. Harvard-Smithsonian Center for Astrophysics. Ready for its close-up, new technology sharpens images of black holes. Science Daily. ift.tt/lsgz1wq. Accessed August 16, 2022. Thanks for watching. Please subscribe my channel for more videos.